Good evening, everyone. I'm back again with another video. Today we'll be doing trigonometry. I'll be introducing these three functions of trigonometry, and after that we'll be doing examples on how to answer questions relating to this. If you see here, we got three functions here. The first one, I hope you can see there, is y is equals to a sine into bx plus c plus q. You might be wondering what the functions of a, b, c, and q are here, and I summarized them below here. And before we proceed any further, I want to show you this here. You must know these three trigonometry graphs by heart. These three here, starting from 0 to 360, using the 90, 180, 270, and 360 degrees interval. And I think it can take you like maybe 5 minutes to know this here. They're not that hard. You just know that the sine starts from 0 and the cos starts from 1. And the tan does not change. It is like this, you know, it is different from the rest. And you can tell just by looking that this is a tan graph. Here's a little bit hard, but if you know that sine starts from 0 and cos starts from 1, then you are done. Let's proceed here. I said here that the function of a here, which is this a in front of sine here, you can see it's in front of every function here. I stated that the function of a here is to determine the amplitude. Someone might ask what an amplitude is. This is an amplitude here. The distance from the midline of our wave here. The midline of our wave cuts the wave here into two equal parts. We have the upper part and we have the lower part. The amplitude is the distance from the midpoint here, the midline here, to the peak. It is the distance from here to the peak, which is 1, and also here to the peak, which is 1. This is what we are referring to when we say amplitude. And one other thing that a does is that it shifts the graph up and down. Let's say, for an example, in this standard sine graph, the a value here is just 1. You can see here, I mean, obviously 1 is not there, but you can just tell that 1 it is there. And like if we put 2 here, this graph, this function of this graph will shift like this way. If you put 2, it will do this. If you put 3, it will do this. And if you put 4, it will do this. Like it shifts up and down at the same time. It's like stretching this here. Stretching, I mean compressing or stretching this. If you put maybe let's say half, it will shrink like this, and yeah, you get the idea. And the function of let's see, the q here, the q which is here. The function of the q is to determine the y-intercept. If q is 1, that means the y-intercept is 1. If q is 0, that means the y-intercept is 0. And one other thing that it does is that it shifts the graph up or down. Here it shifts the graph up and down. Here it shifts the graph up or down, like this here. If I say sine x plus 1, this graph will, sine x plus 1, it will move like this. Sine x plus 2, it will move like this. Sine x plus 3, it will move like this. And we said in the a value, it moves this way. If it moves up there, at the bottom, it moves down. If it moves up at the bottom, I mean, if it moves up at the top and at the bottom, it will also move down like this. But in q, if q is positive, it will move like this. And if q is negative, it will move like this. I hope you get the idea. And the function of let's talk about B, no, before we talk about B, let's talk about the horizontal shift here, C. What C does is that you can see where it is here, C. What C does is that it makes the horizontal shift. If we add by, let's say for an example, we say sine x plus 30 degrees, that means you are moving to the left, like I said here. If we are adding, that means you are moving to the left. If you are subtracting, we are moving to the right. And if let's say here, instead of sine x, I said sine x plus 30 degrees, that means I'm moving to the left. Where my graph intercepts, like it intercepts the x-axis at 180 degrees. If I say plus 30 degrees, I have to minus here. And 180 minus 30 is 150. Instead of crossing here, it will cross somewhere here at 150, like this. At 150, like this. This is why I say it causes the horizontal shift. And I will show you an example in a few seconds or a few minutes. And let me explain the period, what we're talking about when we talk about this concept of period. The B here determines the frequency. If let's give a numerical value of B. If B here is true, that means in a space of 360, we will see, in a space of 360, we will see true sine graphs. And if it's if B is 1, that means in a space of 360, we will see a 1 full cycle. And if B is half, that means in a space of 360, we will only see half a sine, or half a cycle. Yeah, half a cycle. If B is true, that means in a space of 360 we will see true sine graphs like this. And I will show you examples as I continue to illustrate in the after explaining these concepts, I will show you what they mean and so on and so on. It determines the period, or determines the frequency of the amplitude. And then we move here where it says amplitude. I know there are several ways to calculate the amplitude. You can use this formula here, or you can you just say the highest point plus the lowest point divided by 2, like here. If you want to determine the amplitude, you just say the highest point, which is 1, plus the lowest point, which is -1. But here you ignore the negative sign here. You just say 1 plus 1 divided by 2, which is just 1. It will give you an amplitude here, which is just 1. And then when you are calculating the period for sine and cos, you just say 360 over frequency. And I told you that the frequency is the B value here. You just take whatever B value is there, you divide it by 360 for sine and cos. But for tan, you don't, the period of tan is 180 degrees. If they ask you to calculate the period of a tan and they give you a new frequency, you just take that frequency and you just take 180 degrees and divide it by that frequency, and you will get your period. I believe you are done with this theory here, and I'll show you how to sketch some few of these functions here. If you don't mind, I'm just gonna pause and do some few things and unpause so that we can continue. We are back again. What I did here is just I drew the sine x graph here. This is the sine x graph, and we increased the interval. We are using the interval of 30, 60, 90 up to 360. That's why it looks it doesn't look like they do look alike, but I hope you can see. And what I did is just I extended the interval here. That's why it looks like a sine x graph. But what we are required to do here is that we are asked to draw the the graph of y is equals to sine x plus 30 degrees. And like I said here, when they say plus, that means you are moving to the left there. If they say minus, that means you are moving to the right. And so most might use the table method, but that table method is for grade 10s and grade 11s, and maybe the examiners might penalize you, or they might, who knows. Here in grade 12, before you sketch anything, you must make sure that you have the x-intercept, the y-intercept, the turning points, and all of that. And after that, you sketch those axes there. What you want to do here is that whatever point is here, whatever point this graph intercepts, like here you can see it intercepts at 180 degrees and at 360 degrees. Instead of it intercepting here, since you're moving to the left, you will add everything by, you will take away 30 degrees from every interval that this graph intercepts. What I'm saying is that instead of 180 degrees, you will say 180 degrees minus 30 degrees, which will give you 150 degrees, like this. You plot here. And instead of 360 degrees, you will say 360 minus 30, which will be here. Instead of 0, you'll say 0 minus 30, which will move to the left a little, and this is how your graph will look like after you've made this adjustment here. This is what it would look like. What I did is that on each intercept here, I minused, or I subtracted 30, because you are moving to the left. If they say x minus 30 degrees, that means you would have moved to the right. But since it is a plus here, that means you are moving to the left. The turning point here on the original graph that we were given was at 90 degrees. But our new graph here turns at 60 degrees. As you can see here, 60 degrees. Everything here moved 30 degrees to the left. I hope you can catch that. Here you can see it was turning, the original graph, this blue graph here, it was turning at 270 degrees. And if I say 270 degrees minus 30, it will turn at 240 degrees, like you see here. You see here. And that's just it. If you want to draw, if you want to sketch these trigonometric graphs, it is just so easy. Instead of using the table method that will consume your time, you just do this. And yeah, I just want to conclude this video here. I will come with more examples on how to answer questions based on trigonometric functions and stuff. With that being said, I will see you in the next video. Bye.